Hello, everyone. My name is Ahmed Al-Ayat. I lead product for NDB, Nutanix Database Service. And we're very excited to be kicking off our first NDB Tech Talk. This is kind of a series of talks that we want to do where we give you more information about NDB, the Nutanix Database Service. And this is not a marketing or sales or any type of that's not the idea with this talk. It's really to get into the details behind certain features and capabilities that NDB has. It's meant to be a very interactive session so that we can get your questions answered and you can directly speak to the builders of NDB. So the product team, folks on my team, and the engineering team of NDB. So basically the builders and architects of NDB. And we want to basically uncover the curtain, if you will, into some of these capabilities. So without any further delay, it's my pleasure to introduce both Raghu and Susindran, who will take us through Time Machine. We're planning to have a couple sessions on Time Machine, since it does have a lot of capabilities that we know you all are interested in. And there'll be a series of these tech talks. We hope to have them either monthly or bi-monthly. So please keep an eye out for that. And we hope you enjoy this session. Like I said, it's very interactive. So as Raghu will let you know, anytime, please feel free to either raise your hand, interject, put a question in the chat. Really, we want this to be a discussion and not a one-way conversation. Okay, so with that, Raghu, why don't you take us away?
Sure. Thanks, Samad. And hello, everyone. My name is Raghu, and alongside me, I have Susindran, and we'll be presenting about the NDB Time Machine. So before we get started, just want to maybe a show of hands. How many of you have heard? I'm sure. Okay. How many of you have not heard about NDB in the past? Just want to make sure that uh, everyone is aware of NDB Nutanix Database Service. If there's anyone who's not aware of NDB, maybe can raise hands. Okay, so I don't see anyone's hand lifted. So I'm assuming that everyone is aware of Nutanix Database Service. Okay, just one more question, maybe show of hands. How many of you are hearing about the term time machine for the first time? So if you are hearing about time machine, NDB, Nutanix Database Service, time machines for the first time, anyone hearing it for the first time, maybe you can go to your chat and raise your hands. Anybody? Okay, great. Looks like most people know about NDB, most people know about time machines, so that is a good start for us. If anyone has not heard about, please add a comment and then maybe I can explain more. So, getting into the agenda for the session. As Ahmed mentioned, this we want to keep it as interactive as possible. So feel free to interject, and Kanchan and Susindran and Ahmed are also on the panelists. So they will see if anyone has raised their hands and they will interject. So the first thing that we'll be covering is about time machine, right? Time machine backups. So we'll also be covering about time machine versus traditional backup tools and how what are the benefits and what are the good things that time machine does. We'll also get into the time machine architecture. When I say architecture, we'll talk about the snapshot-based architecture and the log-based architecture. And if time permits, we'll try and do a short demo around how NTB works. So this is just an intro slide for those of you. As most of you know, Nutanix Database Service, we do a lot of good stuff. We do provisioning, patching, time machine stuff. Today, the session that we are covering is time machine backups. We'll also be covering time machine recovery and cloning, right, in a future session. So just to set background, so today will mainly be around backups and how we go about it. So time machine backup, right? So time machine is basically the backup offering from Nutanix database service, right? The most important piece of the time machine or time machine is composed of two important things, right? So the most important thing is the snapshot and the other is the logs. So when you say snapshot and logs, a combination of those form the time machine. So from a snapshot perspective, right? Snapshot is application consistent. So for those of you who are DBAs, you will understand. So we freeze the database, queries the database, and we take snapshots, right? So that these are application consistent and always like application aware. All transactions are frozen, and then we take the snapshots. The next, so the snapshot that we take is based on Nutanix AOS. So Nutanix AOS is takes disk-based snapshots, right? So we have volume groups and VM disks for SQL Server. So we take disks-based snapshots, and as you know, right, Nutanix AOS snapshots are redirect on write algorithm, and they are space efficient. They are really fast. So I'll not talk too much about those, but we depend on Nutanix AOS for all of the snapshots that we take. So this is around snapshots, right? And typically snapshots are taken once a day. You can take up to 4 snapshots a day, but uh, typically customers take like about 1 snapshot a day, right? And apart from snapshots, we have transaction logs. Inside transaction logs, right, for all of the database engines that are supported in NDB, right, we take the respective logs. So for SQL, we take SQL native log backups. For Postgres, we take write ahead log, right, wall logs we take. Um, then for Oracle, we take Oracle archive logs. For MongoDB op logs, and for MySQL and MariaDB, we take bin logs, binary logs. So when we say log backups are captured, right? And we basically help you move it to uh, either we help you move it and store it so that the combination of snapshots and logs can be effectively used for any kind of recoverability event. Since snapshots are local on the Nutanix cluster, they are space efficient, they are really fast. So most of the recovery that is seen is really fast. So as I spoke, a snapshot plus logs, we help you achieve recoverability. Point in time recovery is achieved with the help of these transaction logs that we capture for each of the database engines. Feel free to stop me, interject me if you have any questions around any of these things, right? Moving ahead, right, for backups, there are 3 important things, right? So the first thing is retention, right? So we allow for obviously point in time recovery or continuous recovery. So continuous recovery retention is offered. Then you have retention for your daily snapshots. You can have weekly snapshots. You can have monthly snapshots. So on and so forth, right? So we allow the retention for all of these, right? And from a frequency perspective, right? So we help you set up a schedule for when you want to take your snapshots and how frequently you want to take log backups. You can take log backups at a minimum frequency of 15 minutes is what we offer with NDB. So the next thing is, apart from the retention and the schedule, the an important feature of NDB Time Machine is we help you replicate your backups. When you say backups, it includes both your snapshots and logs to NCI and NC2 clusters. So you would have already registered Nutanix clusters with NDB. You would provision your databases, you would associate time machines with these databases, and you can, once you have set up your time machines for these databases, you can replicate these to alternate Nutanix clusters, right? And these clusters can be either NCI cluster or NC2 clusters on AWS and Azure. On this slide, if anyone has any questions, let me know. I think, okay. Okay, I don't see any hands raised or any comments, but please feel free to interject if you have any questions. Okay. I'll go to the next slide. Right. So time machines versus traditional backup tools. Right. So when we say time machines, as I spoke about, right, snapshots are AOS snapshots, right, and typical snapshot operations complete within minutes. Um, in traditional backup tools, you would typically take full backups, right? And these full backups are typically proportional to the size of the database, right? So if your database is about 10 terabytes, or like, I mean, typically 10 terabytes take a couple of hours, right? In traditional backup tools, which can be done in a few minutes within NDB, right? Since it is a snapshot based operation. From a storage perspective, again, as I said, snapshot is a redirect on write. So we have new data blocks that is written, and we maintain metadata pointers to these snapshots. So does not consume as much storage if you would have taken traditional backups. Traditional backups, again, full backups, directly proportional to the size of the database. Again, right? If you have a 10 terabyte source, then your copy will also be of 10 terabyte if you're taking a full backup, right? So storage efficient snapshots, right? From an RTO perspective, as I said, snapshots, again, metadata pointers. Log backups are also maintained in object stores, which we can easily connect with Nutanix objects. So the RTO typically is in minutes. You can recover your databases, create your clones. So all of this is really fast with NDB, right? With traditional backup tools, again, right, you need the whole backup. So 10 terabyte or 40 terabyte backup that has to be downloaded, and then you need to perform native restore, right? So these are some benefits over traditional backup tools from a time machine perspective. So Sindran, do you want to like add any other points that we have missed? I think we've covered most of it, but if I've missed anything, we can cover in these two slides. If not, if we are okay, then maybe Susindran, you can get into the architecture, and I think a lot of people would be interested in knowing about that.
Sure, Raghu. Thank you. Let's give it a few time to see if we have some queries as well. We can then take up those questions.
Yeah, and if anyone wants to ask a question verbally, just raise your hand. I will enable audio for you.
Okay, we'll get started on the architecture of the snapshot from time machine perspective. Hello, everyone. I'm Sushindran. Good morning, good evening. So this session we want to go a little bit deeper on how NDB performs the snapshot workflows and the log backup workflows, such that we will try to understand the intricacies of how we do these workflows and how NDB is able to perform the snapshot within minutes. So basically, NDB has three interaction points. One is our UI, the other one is CLI, and then we have the API, REST API client as well. So via these three interaction points, you can ask for a snapshot, or you can schedule a snapshot for your databases. When the request arrives on the server, we take the request and then we format a work for it, and then we post it in our Postgres metadata. And now all the DB server engines, basically your database VMs, we have a small agent that runs in the engine, so which is called NDB daemon agent now. So NDB daemon keeps talking to your Era server every 10 seconds and then asks if there is a work for me to do. So now when the snapshot operation comes, the DB server VM gets that particular snapshot to work now. When the snapshot work comes, what NDB performs now is we do basic validation. That's the first thing that we do. And if the database is healthy state, if this is the node which is the right node for me to take the database, we perform all these validations. Then we go into the critical step of how we take the snapshot. So the snapshot operation has three critical steps. One is the queries of the database. Second is the taking the snapshot of the disks, and third is the unqueries. So these are the three critical operations that we do as part of the snapshot operation. So the queries database, for a very brief period of time, pauses the writes on the database now. And once that is done, we go and take the snapshot on the Nutanix cluster. Like Raghu mentioned, it is going to be the read-write algorithm for us. So the snapshot is going to be very fast. And then typically the call comes back within few seconds. Once we receive the response or that the snapshot is taken on our Nutanix cluster, basically where your database disks are residing, we then unqueries the database. So this operation itself will just take a few seconds to complete, from briefly around 10 to 15 seconds to complete. So within this particular 10 to 15 seconds, we are able to take a snapshot on the Nutanix cluster, and the database is up and running for all the other transactions. Now, once the snapshot is cut, you have the snapshot ready to recover at any point in time. So this is the core piece on how we are taking the snapshot and how we are able to give a faster snapshot than your traditional full backups or native full backups. Another one more aspect that I want to talk about the snapshot is where can I preserve this particular snapshot? Where can I keep the snapshot? Currently, when we take the snapshot, we take at the source where the database is present, but the snapshot can be moved to any other Nutanix cluster, which is running anywhere, as long as it is registered with NDB. You can move the snapshot to cluster 2, you can move it to NC1, you can move it to NC2. So you have the data of that particular snapshot available across all these places for you to recover. So this on a very high level is how your snapshot operation works from NDB. Any questions that I can take? We have a question. So, Kanchan, can you look?
Okay. I think one of the guests has raised his hand.
Yeah, I
Yes,
think you unmute yourself.
yes. Can you hear me?
Yes, we
Yes.
can hear you.
Okay, my question is about the snapshot. If we keep it on another Nutanix cluster in the restore, the time for the restore will be more than if we host it on the same cluster. Yes.
That's correct. It has two different variants for it. It depends on which is the snapshot that you're restoring. If you're talking about latest snapshot restore, which would be always present on Nutanix cluster, the restore is going to be faster for you. In case that particular snapshot is not on the primary cluster, if it is kept on the secondary cluster for a longer period of time, then that particular restore will take a little bit of time because we need to pull the snapshot back to the primary cluster.
Okay, thanks.
Any other
There's a belief, there's a question on Q&A by Srinivas. Can you talk about the immutability capability of the snapshot? How can we get it protected?
Yeah.
Susindran, do you want to take that question?
Yeah, immutability of the snapshot is currently available on the PC world, but NDB does not work in the PC world yet, where we can protect your databases or the VGs or the disk in a protection policy, and then we can enable the immutability.
So actually, Susindran, let me answer it this way, right? I would actually answer it this way. So the snapshot, by nature, the data part of the snapshot that we store on AOS is immutable. The data cannot be changed, especially given that we do a copy on write, which implies that all new data, when we take a snapshot, all the V blocks, all the data associated with that point in time becomes immutable even from within the AOS side. All new data that's written is written to new blocks. And those blocks are mutable until the next snapshot. The log that the intermediate log points that we capture, and I think like our Susindran hasn't gone all the way till that point, but the logs that we capture in between these AOS snapshots for the recovery, those are also placed when we place it in the object store. By definition, that becomes also immutable by nature of the object. If it is placed in AOS, that is also made immutable because we put that log data in the construct of what is called as a vdisk within AOS, and we snapshot that vdisk to make it immutable. So the immutability of the snapshot data is guaranteed. Now, there's a second part to it, which is, I think what Susindra was mentioning. There's an immutability of the snapshot as a construct itself, which is if an admin does decide to delete the snapshot through the management plane APIs, which is like either the REST APIs or through the UI, then those snapshots can get deleted. Now, we do have within the Nutanix product a construct that prevents the deletion of those the snapshots even with admin privileges. if you enable if you enable a capability to have a multi-party authentication, which is the policy would define that can define that for any management plane operation, which is through API or through the UI, you will need authorization from multiple parties before the deletion can happen. So that is something that NDB we're working towards consuming this feature that's available within the Nutanix, broader Nutanix product, which is exposed through PC. We are working towards integrating that within our product. That's a project that's going on. So I think that's what Susendran was mentioning. But the data itself, we have immutability. Hope that answers the question, Srinivas. Okay, cool.
Thanks. Thank you, Bharat. I think we'll move on to the, if there is no more questions around snapshot, we can go to the log backup architecture. Cool. So the process of taking the logs would be similar to the process of taking the snapshot in terms of how the work is submitted to your NDB VM. So like I said, it could be we are having a scheduled operations where your log backups will be taken at every 15-minute or 30-minute or whatever is the configured time that you want. So at present, our lowest time is 15-minute for objects. So every 15-minute, we will be able to pull the logs out of the database and then keep it in our object store. So how that works is we have a schedule that keeps running at NDB server layer. At every 15-minute, NDB server layer will post a work for the DB server VMs where the database resides to take the log backup. So DB server VM, like I said, will be listening to the work from the NDB server. It will once the work is submitted, it will pick up that work. We have the NDB daemon which actually picks up the work. When we know that we need to take the log backup, it tells the database saying that, hey, I need the logs. So when we call the database to take the log backup, we will give the location where the logs has to be present. And that location is our NDB drive, which is a small staging drive that's present in the DB server VM itself, where for a shorter duration of the time, we keep the logs in that NDB drive, such that all logs are taken much faster. Now the logs are moved to the database, the NDB drive. There's another smaller operation that runs in the background, which pushes these logs from the NDB drive to the Nutanix object stores. So this is the logs present in the object store is for the longer duration of the time based on the SLA that is present. And the reason that we do not keep the logs in the local database server itself is because we don't want these logs to be hampered for any other reasons. So we always move the logs to the Nutanix objects, which NDB controls over it, has metadata management and everything that NDB takes care of it. So this metadata is then pushed back to the NDB server, such that NDB now is aware of all the snapshot that was taken, the metadata of the snapshot that it is taken, and the logs locations and everything. So with collecting the combination of all this data is what will be presented in your time machine view, your snapshot, your logs, and when the logs are going to be taken. And this particular data that is presented in the time machine view is what we will be using for the recoverability purpose as well.
Hey, Susie, we have a question in the chat from John saying, how will this interfere with traditional backup solutions such as Veritas?
So when it comes to the log backup, for SQL Server, it depends on engine to engine actually. When it comes to your PG database or Mongo, I think the oplogs can be copied by both the tools. The interoperability between third-party operations is something we are working on now. But when it comes to another engine called SQL Server, that might not be possible because traditionally NDB truncates that particular log.
Yeah.
So this is something we will have to work on engine to engine basis. But generally, if Veritas also takes a log of say PG or Mongo, and NDB also takes the log of PG or Mongo, we should be able to manage them both.
Yeah. Just an update on that. Yeah. So we've been working with a couple of third-party backup tools, and Postgres we've already tested, and we have not seen any issues, right? This tool, again, the third-party backup tool, they installed their agent on the DB server VM, and they have captured database, basically capturing the database backups, and also enabled NDB Time Machine. So from a Postgres perspective, I think we're good. Again, for AHV versus ESX, again, we have seen some issues, again, from a VM snapshot perspective. So where customers are taking VM level snapshots, and when they're taking VM level snapshots, ESX level snapshots, which could basically conflict with the snapshots that we have taken. So long story short, I think as Susindran mentioned, it is database specific, first thing. The second thing is whether it is ESX or AHV, right? So that also has some issues there. But for, yeah, as you said, Oracle and SQL Server, yeah, Oracle should be fine. SQL Server, again, two backup tools simultaneously cannot truncate logs, right? And copy only logs do not work in the long term. So any one backup tool should basically capture the logs and truncate those. So from a SQL Server perspective, so if you're whatever is your strategy, if you want to take like full backups using a third-party backup tool, you take that on a daily basis and enable NDB time machines with point-in-time recovery. But if you're using NDB time machines and you're also capturing log backups using a third-party backup tool, then make sure that you're using only snapshot-only backups using NDB if you're doing SQL Server. Oracle, again, should be fine, right, Susindran? So
we have Adil Rathar, who is Oracle DBA from our engineering DBE team, and maybe like no other can take up this particular question. Kanchan, can you give audio access to Adil as well?
I think I was able to do that. Anil, can you go ahead?
Yeah, hello, hi everyone. Yeah, I think as Raghu mentioned, yes, it works well with Oracle because truncation doesn't help on like even if third-party vendors take log backup. It's just that the third-party any tool that is taking the backup shouldn't delete it before NDB has also taken a backup of that. That's the only conflict. Otherwise, it should work fine if they are not deleting the logs on taking the backup.
Yeah, and just to add to it, so I think the way we are approaching this is this is a combination of database engine and the backup vendor. What we are working towards is working with the backup vendors as well as testing with the database engine to figure out to make sure like the combinations of backup and the schedules and the way it's set up works well. So that's an activity that we are heavily invested in. Again, I think like what Raghu mentioned, we are already working with our backup vendor partners to get a clear operating guide towards for the various databases.
Okay. So thank you, Bharat. And that's the overview of the log backup architecture as well. And we have spoken about how the snapshot works. We've spoken about how the logs work now and how we place the snapshot in different clusters and how we manage the snapshot metadata and log metadata. I think now I'll hand it over to Raghu to give you a brief demo of how the time machine feature works in NDB. Thank you.
Let me know. I am sharing screen, so quickly, just letting customers or all the panelists and the attendees know how NDB time machines are set up, right, for the benefit of those people who have not seen the UI in the past. So basically, when you are provisioning your databases, right, here I will choose an Oracle single instance. So I will choose a registered database server, and during provisioning, right, with this I need to provide Okay. Yeah. So this is where most of the time machine setup is done. As I spoke about, three things, right? First thing is the retention policy, or what we call as SLA. Second is schedule, and third, I will talk about the replication. So the first thing is the schedule. So in NDB, you can define out of box, or basically you can define your SLAs, predefine your SLAs, and give them any name you want. So let me, I have defined, or we have defined multiple SLAs, and we have kept. So I'll choose one of these SLAs. In this SLA, what we have said is that we want continuous recovery for 7 days. When I say continuous recovery, it's point in time recovery, where we use the log backups. Beyond that, we want 7 days of daily snapshots. Beyond that, we want 2 weeks of weekly snapshots, 2 months of monthly snapshots, and 3 quarters of quarterly snapshots. So again, these are the snapshots, and as I said, continuous recovery. So this is where you set up your retention policy, and for how long do you want to maintain your snapshot and logs. Again, the second part I spoke about is the schedule, right? At what time do you want to take your snapshots, right? You can choose whatever time do you want. Maybe at 10 a.m. you choose, say that your daily snapshot should run at 10 a.m. You can choose number of snapshots that you want. We would suggest customers to typically take one snapshot a day, but if they are just relying on snapshot only backups, as we spoke about for SQL Server, there might be a scenario where you cannot capture logs, right? So then you capture uh, multiple snapshots during the day, and then you can choose your log catch-up frequency. As I spoke about, 15 minutes is the minimum log catch-up frequency that we offer, but we offer other 30 minutes, 60 minutes. So for your lower tier databases, you can choose maybe snapshot only backup, or if you want to have, if you don't have a very aggressive SLA, just choose maybe logs to be caught up every 3 hours or 1.5 hours, and so on and so forth. Weekly snapshots, you can, again, as I spoke about, weekly snapshots and monthly snapshots, quarterly snapshots. So you can say that you can capture the weekly snapshots on maybe a Thursday or a Friday, so on and so forth. And monthly snapshots, you choose which day of the month you want to take snapshots, right? So this is where you set up your retention, and this is where you set up your schedule for your time machines. So once the provisioning is complete, once your databases are provisioned, so then you will basically see your databases, and for those databases, you will see a time machine associated. So then you can go to your time machine, right? In the time machine, you will see this kind of a calendar view, right? Which shows you what is the recoverability that you have available, right? So all of the greens shows continuous recoverability available. I will cover about the recovery and how we do recovery and cloning in the next session. But in this session, I'm just showing you the timeline view of how recoverability is shown. Um, we also show all of the different snapshots, when those snapshots have been captured. If you delete those snapshots, what is the reclaimable space that you get? On which clusters have these snapshots been replicated? Uh, Here, yeah, so I spoke about retention, I spoke about frequency, and this is data access management. This is called the replication. So this is where you replicate your snapshots and logs, right, to alternate clusters. So if you have added the cluster to NDB, Nutanix, so if you have added the particular NCI or NC2 cluster to to NDB, you choose the cluster, right? Let's assume I choose this cluster, and I say that on this particular cluster, can you set up a different SLA? So on my primary cluster, I had continuous recovery for about 7 days. I had weekly retention for so many days. But on my secondary cluster, I just want to keep maybe just weekly snapshots or only daily snapshots for a few days, right? So you can have a different SLA setup for your replication cluster. And this is how you can add your replication policy, or here we call it data access management policy. You can also see here, right? So this is your source cluster. So here I have a rack database, and this is a time machine, and this is replicated to all of these clusters. So you can see one of the policies here, right? So one of the DAM policies. And I spoke about the snapshots that you can see. And this is how basically we enable recoverability using the snapshots and logs. So I spoke about retention, I spoke about the frequency, and I also showed you how you can replicate your snapshots. So this is pretty much what we do from a time machine perspective. Time machine again is going through some improvements. We're building better dashboarding and better reporting around all of these things. So, but again, that is future looking, but just wanted to bring up that point. But this is the view that we currently show. If anyone has any questions, recoverability and how we create clones, how we do point-in-time recovery, and details of and maybe architecture of how we do all of those things will be covered in the next session. This was a short demo of how you set up time machines, and once you've set up time machines, how you go and check your time machines and how you replicate your snapshot and logs to an alternate cluster. Also, you can take some ad hoc snapshots as well. You can you can just trigger a snapshot on demand, right? And you can choose on which clusters you want the snapshot to be available. You can also trigger a log catch-up, right?